Now, dear students, today I am going to explain very important part in atomic structure, and it is nothing but the nature of electromagnetic particle. Children, you have seen different activities in nature, like when there is thunderstorm, when there is lightning. What happens if we are using the television, or if radio is operating, or similar instances takes place? What happens? We notice the vibrations, we notice the something vibrations in the television or mobile phone or radio. Why? Because the rays or electromagnetic rays, as the name indicates, they are associated with electric and magnetic field with very high frequency, and so the rays they travel. You all must be knowing that nowadays the cable is there for the television, but few years back it was common that people used to have the antenna. We use this antenna, DTH, at our home. So how they work? Actually, the signals are transmitted from the satellites and they are received by the DTH symbol phenomenon. And it is because they are able to be affected by the frequencies which are emitted by any vehicle or lightning, etc. So this is the reason, and so to further study the atomic structure, this is very important point. So children, you all must be knowing Isaac Newton. So Newton was the first person. Newton was the first person who proposed corpuscular theory of light. So I am writing the term light. So light is basically an electromagnetic radiation. All the radiations, all the light of from any source, let it be a bulb, it be from tube light, it should be from the electric spark or from the sun, all are called the electromagnetic radiations because they are associated with electric and magnetic field. So see here, simply here there is the electric field and here there is the magnetic field. So the rays, they are associated with like this. The rays are associated. So this is the main point, and so this is the brief introduction about the electromagnetic radiations. Now coming to corpuscular theory, and Newton was the person who proposed this theory. So Newton was able to explain the simple property of light, reflection, and he was able to explain this reflection as well as refraction. But he was unable to explain some more properties of light, and it is interference and diffraction. So these were not explained by Newton. Interference and diffraction, these are some properties of light. And so actually interference is as name indicates, interference. So there is the interaction, between the particles. And suppose if there is a hard obstacle, there is the obstacle, and if light passes through, just touching the tip, see this is the, if touching the tip, so there is the bending of light rays, and this is something like that of the interference. Now diffraction, there is suppose we pass the light through a solid, let it be the crystal, it is solid crystal, and so as you know, every substance, every material is made up of atoms and ions, etc. So they have fixed dimension, they have fixed radius, they have fixed size. So there is the a scattering of light rays. So this is diffraction. So these were unable to be explained by the Newton. So this was not rejected, it was not validated, because he was 50%, able to explain corpuscular theory. So then there was the concept of wave theory, and wave theory of light, and it was given by Huygens. It was given by Huygens. So we'll focus now on the wave theory. Let's see. Now we will say about the wave theory of light. We may say wave theory of matter. Children, every substance is made up of particles. And the point is that in case of solids, the particles are at rest. In case of liquids, the particles are not at rest. They are mobile. But in case of gases, the particles are always moving. So we refer this term to the matter also. Now coming to wave theory of light. So initially it was given by Huygens, but it was also improved upon by different scientists like Maxwell, James Clerk Maxwell also. So this wave theory of light, as you know, it is of the opinion that any sort of radiations, whether it is alpha ray, beta ray, gamma ray, X-rays, sunlight, any light source, it is always associated with electric and magnetic field. And it means the radiation of all the forms of light, they are always associated with the wave nature. You all know about the waves like transverse waves, longitudinal waves, and their properties. So coming to that point, the features of the wave motion, and so this wave theory, it is there to explain the different aspects of light. And so see here, if it is a mean axis, and so there is crust and the trough like this. This is the crust and trough. Crust and trough is there, and so they are associated with the this electric as well as magnetic field. Now see, this upper portion from this elevation from the mean line, it is called as crust. It is called as crust, and this downward it is called as trough. It is called as trough. Now the distance, the height of the crust, or this depth of the trough, height of the crust or depth of the trough, it is called as amplitude. Now the distance between the two crust or the distance between the two trough, it is called as lambda. This thing. So these are the basic points. So first we will start with some basic points. So the first is the wavelength, and it has the sign. This is called as lambda. This is lambda. It is a Greek word. Lambda is, children, it is Greek word, and it is defined as the distance. It is defined as the distance between two consecutive crust or trough. The distance, lambda is, it is distance between two consecutive. Consecutive means one after other. So now its unit. Its units can be, it can be angstrom. This capital A power node. It can be millimeter, it can be in picometer. So there are different units, and it depends on the type of rays used. Now children, 1 angstrom, here we say 1 angstrom is equal to 10 to the power minus 10 meter. 1 angstrom is equal to 10 to the power minus 10 meter. Angstrom is unit. Similarly, you must be knowing nanometer. Nanometer, nm. And 1 nm is equal to 10 to the power minus 9 meter. Similarly, it can be picometer, pm. It is, 1 pm is equal to 10 to the power minus 12 meter. So similarly, all the rays, they have some wavelength. And so, this is the first point. Now children, second point is the amplitude. Amplitude, and its symbol is A. So similarly, as we have seen here, the height of crust or depth of trough is called as amplitude. So it is the height of this crust or the depth of trough, and its unit are same. Unit can be in nm, nanometer. Unit can be in millimeter, and unit can be in angstrom. It can be in picometer. So it is the about the amplitude. Now third is frequency. Frequency, and it is this small v like, and it is called as nu. Frequency is called as nu, and this frequency is defined as number of waves passing through a point in 1 second. So number of waves passing through a point in 1 second. In 1 second, how many waves are passing? So its unit will be hertz, Henry Frederick Hertz. So 1 hertz, it is the SI unit, and so 1 hertz is equal to CPS, cycles per second, or second inverse per second. So this is the 1 point. Now children, next, fourth is the velocity. Fourth is the velocity. We saw, as you know, velocity is simple. The speed or the distance traveled by a wave motion. Distance traveled in meter in 1 second by a wave motion. So simply the unit will be meter per second or meter inverse. Now the last part, children, in this is wave number, and wave number, it is so it is nu, and there is a line of it is called as nu bar. So it is this symbol, it is called as nu bar, and it is defined as number of wavelengths which can be accommodated in 1 centimeter length in the direction of propagation of light. So it is defined as the number of wavelengths which can be accommodated in 1 centimeter distance, 1 centimeter distance in the direction of propagation of light. It means it is the distance, it is 1 centimeter, and how many wavelengths can be accommodated in 1 centimeter distance in the direction of propagation of light. It means light is going or any ray is passing through, and so distance is 1 centimeter, and so how many wavelengths can be accommodated, and it is called as, it is called as wave number. And this mathematically it can be written nu bar is equal to 1 upon lambda. This is this mathematical relation, and its unit it is centimeter inverse. It can be meter inverse also. So depending on the nature, it can be centimeter, simplest unit centimeter inverse, it can be meter inverse, and so. Now children, we will see the last portion, the relation between this frequency, wavelength and wave number. So children, simply it is denoted as this C, velocity of light. C is equal to nu lambda. C, where C is velocity of light. It is standard, and this nu, it is frequency. It is frequency of light, and this is wavelength. So this is the very important relationship, and it is there. We call C is equal to nu lambda, or it can be said as, or it can be written as nu is equal to C upon lambda. This is the second point. Nu is equal to, frequency is equal to C upon lambda. It means the light's speed can be this divided by this, and so we get the point. But what? This nu bar is equal to 1 upon lambda, or you may write lambda is equal to 1 upon nu bar. So we can relate this, we can apply this and see how. So on comparing this, we get the very important point, and it is the point to note that it is very much important, and this it is actually nu. Frequency can be calculated, and this frequency nu is equal to C upon nu bar. So this is the children third. So this is the first, and this is the second, and this is the third formula. And so this is very important to note how the different terms they are used in this wave theory of matter, or rather wave theory has become integral part, and so in all the conditions it is related and associated.